All right, so 7.5, we're going to be looking at the last two of our quadrilaterals. We're looking at trapezoids and kites. And it says, what are some properties of trapezoids and kites? We do need to know what a trapezoid is and what a kite is. Okay, so that's really important. So on this first picture here, letter A, I wrote down what a trapezoid actually is. So you can see that right here, it's a quadrilateral. Quadrilateral with one pair of parallel sides. So one pair of sides that is parallel. And you can see I circled those. And we call those sides bases. So here's one base. Here's your second base. So the bases are the ones that are parallel. The other two sides are not parallel. They are not going to be going the same direction. They're called legs of the trapezoid. Now, if the two legs happen to be the same length, then it's isosceles, just like the same length in a triangle is isosceles triangle. If you have the same length in a trapezoid, we can call it an isosceles trapezoid. So these are the legs. This right here would be called isosceles trapezoid. And it's because of the two equal legs. I put the tick marks there. And because the two base angles are the same down here, that's why the two legs are the same. If you ever see two angles the same, then you know you got two legs the same. That's an isosceles trapezoid. If these two bottom angles were different, then the legs would be different. It would just be called trapezoid. It wouldn't be isosceles. As we move it up, you can see that is the trapezoid isosceles. And I wrote that only if the two legs or base angles are congruent. This one is yes. This one is isosceles because the base angles are congruent, comma, the legs must be congruent. Since the base angles are congruent, the legs must be congruent. So we just call that isosceles trapezoid. It's got two equal sides and two parallel bases. The bases cannot be congruent as well, then you'd have a parallelogram. You don't want that. So you've got to have two ones that are parallel to each other, the other two are not parallel. That makes it a trapezoid. And C, I just wrote down a couple of different trapezoids that you might see. Okay, there's a regular or just a trapezoid where you don't have anything equal, but we will always, in every trapezoid, one thing that will always happen is your consecutive interior angles, the angle from top to bottom between the two bases, will always add up to 180 on both sides. Because you got parallel lines, the angle on top and the angle on the bottom are going to add up to 180 degrees. Because they're between parallels, they have to add up to 180. And same thing on the other side. The one between the two bases have to add up to 180 degrees. They have to be supplementary. That's just in trapezoid. We do have one we can call a right trapezoid. Over here, right trapezoid is one that has two right angles. But you can see that 90 and 90 makes 180 anyways. So those between the two parallel lines are going to be 180. So that is just about a trapezoid. Those are about trapezoids. So this whole front page is your trapezoid page. Kind of tells you about them. Gives you some characteristics. Tells you what ones are called bases. If you see the parallel ones, those are the ones that are called bases. And then the other two are called legs. So in these bottom ones, you know that this top one is called a base. This bottom one is called a base. And the other two are legs. Same thing on this second one. It's the top parallels a base, the bottom parallels a base. Okay, so that is trapezoids. One pair of sides parallel makes a trapezoid. One pair that's parallel. two pairs parallel makes a parallelogram. One pair parallel makes a trapezoid. The kite is the next page. And the kite you may have seen before. I know when I was a lot younger, probably even younger than you guys, we used to go to, Toys R Us. That was still back in the day. And we would buy, if we got it, we wanted to buy a kite, we bought a kite. They were usually pretty cheap. And they came in a plastic tubing bag because they put two sticks in there. And then they put the cloth. So you take the two sticks and you put them together. How do you put them together? In a kite, how do you put the two sticks together? Like a plus sign or a cross, right? And it has to be 90 degrees there for you to have the kite come out right. So when you put your cloth on, the kite comes out. You have the plus sign or the cross in the kite. So that tells you one special characteristics about a kite is that those two sticks were perpendicular, or the two diagonals we're going to call them. You are going to have perpendicular diagonals. But let's see what an exact definition of a kite is. What is the exact definition for kite? It says it's a quadrilateral. Okay, so yes, we know that because it's got four sides. And it's got two pairs of consecutive congruent sides. Okay, see if you can think about what that really means. Two pairs. So you got a pair on one side and a pair on the other. Two pairs that are next to each other, consecutive, that are equal. So do you see how these two sides are next to each other and they're the same? You see how these two sides are next to each other, they're the same? So these two are the same, that's one pair. These two are the same, that's the other pair. So two pairs of consecutive, congruent sides. If they were opposite congruent, it would be a parallelogram, because the opposite angles and the opposite sides were congruent in a parallelogram. The kite means there's two pairs of congruent sides that are next to each other. Now, there's also one other thing about the kite is that one pair of angles, this angle and this angle, are going to be equal. And they're the angles that are separating the one pair of congruent with the other pair of congruent. So this pair of congruent and this pair of congruent are separated by two angles that are exactly the same. That's how they're separated. Okay, so those are the congruent angles. So that's your kite. That is all the stuff about a kite. Make sure you put the right angle box. So there's one last thing, is that the one diagonal gets cut in half. Not both of them. I mean, you can see the long one is not cut in half. Half would be way over here somewhere. But this little one is getting cut in half. So one diagonal does get cut in half because of the equal angles. The other diagonal is not getting cut in half. But you will also see in a kite that these angles will be bisected. So you'll have angles that are bisected there too. So there's quite a bit of stuff in the kites. You got perpendicular diagonals. You got congruent sides that are next to each other. You got one diagonal that's bisected. You got two angles that are bisected. So there's a lot of stuff going on in that kite. That's why I tried to put it all in that picture so you could see it. What are some properties of kites and trapezoids was our essential question. So I just said see diagrams. I gave you every information and I gave you all the tick marks and all the arcs on the diagrams. So look at the diagrams and you'll be able to see all the stuff that's true about a kite and a trapezoid. Okay, so let's look at 4 and 5. Let's see if we can do these two. Is the trapezoid at the right isosceles? And it says explain. So if you see two equal angles, okay, so do you see how they're both 65 degrees at the bottom? So if the two angles are equal, that means the two sides have to also be equal. So you're going to put yes. Two congruent base angles means two congruent legs. Okay, the base angles are the angles that are next to a base. and then the two legs are the ones that are not parallel. So I know right now that those two legs are equal, so it has to be isosceles. The reason they're equal is because the base angles are equal. So your two base angles are equal. That means your two legs are equal. It's isosceles. You could also figure out these top two angles. They both have to be 115 degrees because the two angles together must add up to 180. So they both have to be 115. Those two have to add up to 180, and these two have to add up to 180. Okay, so those have to happen. So yes, that is isosceles. Base angles are equal, the top base angles and the bottom base angles. A quadrilateral has measures of 70, 70, 110, and 110. Is the quadrilateral a kite? Okay, and that answer is definitely not. So no. And I would put isosceles trapezoid. If you have two angles that are 70s and you got two angles that are 110 and they're next to each other like that, you're going to have an isosceles trapezoid. It's going to have two congruent legs because the two 70s have to be next to each other. They're not across. If they were across from each other, you could say it's going to be a parallelogram then. But the two 70s are next to each other, the two 110s are next to each other. So it has to be isosceles trapezoid. All right, so that's your communicate. That's just using the information to answer a couple of questions. Then you've got some vocab next. And I just wrote C diagrams for the first four because we did it all in the diagrams. So I'm not worried about those. I do need you to look at the fifth one, though. The fifth one, actually, no, the sixth one, sorry. These are all on the diagrams, but the sixth one is not. The sixth one is called the mid-segment. Mid-segment of a trapezoid. Mid-segment of a trapezoid is a segment in the middle. Basically, it's a segment connecting two midpoints. So the key word there, midpoints. This point is a middle point because it's got two equal pieces on the sides of it. This one's also a midpoint because it's got two equal pieces on the side of it. So a segment that connects them is called a mid-segment. And a mid-segment is the average of the bases. Average of the bases. And I'm going to put an arrow and I'm just going to put halfway because that's what the average is. It's half of it. Halfway there. It's halfway there. So if you're starting at 10 and going to 20, what's halfway there? What would halfway from 10 to 20 be? 15. Because you could do 10 plus 20 divided by 2. That would be 30 divided by 2, which is 15. Or you could just count halfway. Because your mid-segment has to be halfway between the two bases. So if your base starts at 10 and your other base goes to 20, you just got to think, okay, what's halfway between 10 and 20? And it's got to be 15 there. Mid-segments are midway there. That's midway there means halfway there. So your mid-segments are half. So that's one that you're going to see in the extra practice. We'll do one with a mid-segment. This is the theorems. You just look at them. I already showed you all the pictures already. But I would write anything you see in red. Anything you see in red, I would write down. Each pair of base angles is congruent. Then your diagonals are also congruent. Okay, I would have that written down because if your base angles are equal, then your diagonals will also be equal. Because your angles makes the diagonals the same. They stop and start at the same place. And this one down here says, if the trapezoid has congruent base angles, then it's isosceles. We already knew that. That's just something they wrote again. If you've got two angles on the bottom of the same, then you know it's isosceles, because you know the two legs would have to be the same. So that's 715. So I put that if these two bottom ones are the same, then the two top ones are also the same. So that will be there. Okay, so let's move on to next couple here. So here was our mid segment again. There is two things about the mid segment. I only told you one, that it's halfway. It is also parallel. Okay, so it's parallel to each base. So you could put little arrowheads in there, which they did, and you could put a circle around those because it is parallel to the two bases. It's going to make three parallel lines if you throw in a mid segment. So you got three parallel lines. It's halfway, or it's half of the sum of the bases, and basically it's halfway between the two bases. So it's parallel and it's half of the sum of the bases. So I put the word average over here. That's a good word to use. Halfway means average. Average basically means halfway there. Halfway from one to the other is its average. In a triangle, we were just taking half of the base, but this time you got to go halfway between the bases. Because in the trapezoid, you got two bases. In the triangle, you only had one base. So it's halfway between the two bases. And then I gave you all of this stuff earlier on the kite. I told you that one diagonal got bisected. I told you that you had an angle equal, that you had congruent sides. I told you that perpendicular diagonal. So all that stuff is in the first picture on the kite. So you don't have to do that. But all of this is true about a kite. This whole thing is true. Diagonals bisected, writing, all that stuff that you see on the pictures, it's all true about the kite. So I just showed you the two pictures that they're all true. Everything you see there is true about the kite. All right, that'll take us to our extra practice. And number one takes a little time, but the rest of them are pretty quick. Okay, so number one, we got to do a little graph on. But when you get to 2, 3, 4, 5, 6, 7, they go pretty fast. So let's look at one. Let's get this one graphed. Okay, so show that the quadrilateral with vertices at these 4 points is a trapezoid. Show that it's a trapezoid. So we want to make sure there's one pair of parallel sides. That's what makes it a trapezoid. One pair that's parallel. So 0, 3, you can make a dot at 0, 3, and 0, 6, and negative 6, 0, and negative 3, 0. Now I put the axis, the x-axis and y-axis where I put them because I wanted to give myself enough room to keep it on the graph. So it'd be a good idea to put your x and y-axis in those spots. And then I graphed those 4 points. And we want to connect them. And we want to label them. Okay, so I want to connect this one to this one. And I want to connect this one to this one. It's really not as good as I wanted it to be. Come on. Oh well. Oh well, it's close. All right. So we're going to connect those. So you got a trapezoid. Now the other sides of it that you can see there are going to be this axis and this axis. You got this line here and you got this line here. That's your trapezoid. And you've got Q is the first point. You got R is up here. You got S and you got T. How do I prove it's a trapezoid? Well, I got to prove they're parallel. So we need to find the slope of each line. So slope equals 3 up and 3 over. So if I go to red here for a second so you can see the slope, you go rise 3 and you go run 3. So the slope is 3 over 3. If I go 3 over 3 here, 1, 2, 3, 1, 2, 3, it should still be on the line. So slope of this one is 3 over 3, which is 1. Oops. 1. So your slope is 3 over 3, which equals 1. Here, your slope equals 6 over 6, which is also 1. If you go up 6 and over 6, or up 3 and over 3, you're going to get the same slope. So you could put parallel here. You could put arrows because you now know that they're parallel, and you just proved it's a parallelogram. It's a trapezoid. You got one pair of parallel sides. So decide whether it is a trapezoid. Yes. And you could put QT is parallel to RS. Okay, so that's what makes it a trapezoid, is that there's one pair of parallel sides. Then they want us to find the length of the mid-segment. Length of mid-segment. I'm going to do that in red. So I need to find the midpoint of my midpoint of my two legs. This leg is 1, 2, 3 length, so I need to go to 1.5. So over 1.5 here and 1.5 here. If I connect those, that's my mid-segment. They want us to tell how long that mid-segment is. And I think the best way to do that would probably be to use the Pythagorean theorem. I think we did that before. Let me use green here. So you go up 1, 2, 3, 4.5 up, 1, 2, 3, 4.5 over, and your mid-segment could be 4.5 squared plus 4.5 squared equals c squared. You could have found the length of the two bases and just found the midpoint of that, or midway to them, the halfway point. But I think on a graph, if you want the length of one line, just find its Pythagorean theorem. You guys are really trying today. Thanks. I appreciate it. So we're going to do 4.5 squared. Make sure you don't ask for extra credits and stuff like that if you're not going to work. Because you're supposed to be taking notes right now. 20.25. And 4.5 squared. You get 20.25 again. Add those together, you get 40.5. So you square root that, and you're going to get your length of your mid-segments. So square root of 40.5. You get 6.36 is your mid-segment. So that's going to be your red line right there. And it's also parallel. It's also going to have a slope of 1. Mid-segments are parallel, and they're halfway between the two bases. All right, number 2. I said these are going to be pretty quick now. So if this is a trapezoid, which we know it is because we see the parallel sides, if this is 23, then this angle right here has to be 180 minus 23, because between the two parallels has to add up to 180. So 180 minus 23, you're going to get 157. 157 degrees. And if the two legs are the same, then this is also 157, and this is also 23, because those two bases would equal if the two legs are equal. So they want angle K and L. L is here, K is here. You got your two angles. So that was a trapezoid. Number 3 is a kite. You got two sides next to each other that are equal, and the other two sides are equal. And so that means that the angles between them were equal, between those two pairs. So I'm going to take 90, no, not 90. I'm going to take 360, because the four-sided shape adds up to 360. And I'm going to subtract 90, and I'm going to subtract 130, because I got 90 here and I got 130 here. So 360 minus 90 minus 130. You're going to be left with 140 degrees. So these two angles together have to add up to 140, and they have to equal. So divide by 2, and they're both 70. So you're going to get two 70-degree angles. 70 there and 70 there. You would now add up to 360. And you would have two angles that are equal. A kite has to have two angles equal. It has two pairs of sides equal, and it has one pair of angles equal. The other angles are not equal. So that was 3. 4 and 5 are really quick. You want to know what's halfway between 12 and 36 for number 4. So just take 12 plus 36 and then divide by 2. So 12 plus 36 is 48. Divided by 2 is 24 is going to be your mid-segment. 24. Halfway between 12 and 36 would be 24. You add 12 here, you add 12 here. Let me show you that. If I do a plus 12 on one side, I have to do a plus 12 on the other to make sure it stays in the middle. You got to add the same thing to both sides to make it in the middle. Okay, so that 24 is halfway there between those two. That comes in handy because if I take 0.6, if I add 1.2, that gives me the 1.8. That means I can just take 1.8 and add 1.2. That's going to give me 3.0 as my other base. So if 1.8 is my middle number, it's got to be 1.2 on both sides of that 1.8. So you can just add the 1.2 to both sides. That way it stays in the middle. You've kept it in the middle. And the last two you just need to solve. So 6 is a little tricky because you got to use your algebra. You're going to add the two bases together to get your mid-segment. So you're going to add x plus 11 plus 3x plus 3. And you're going to divide it by 2 to get your mid-segment. So this goes down on this side. Average here. This is the average of the two bases. So if I want to find the average of my two bases, the top and the bottom, I want the average, I got to take them and divide by 2. So the easiest way to solve this one would be to multiply both sides by 2 to get rid of the fraction. But on the right side, you're going to need to distribute, put that in parentheses and distribute. The left side, the 2's are just going to cancel. Your like terms are going to be 4x, and your other like terms are going to be 14. And then you get 6x minus 4 when you distribute. 6x minus 4. So I would just subtract 4x and add 4 to both sides. That way my 4x's will cancel and my 4's will cancel. I'll have 18 equals 2x. When I divide by 2, I'm going to get 9 for x. And it's telling me just to find the value of x, so that would be all I need. So there's 6. And then 7, these are the two equal pieces. Those are the bisected ones. So it's 9 equals 1/10 x minus 1. I would add 1 to both sides to get rid of that 1. So I get 10 equals 1/10 x. And if you want to get rid of a 10 on the bottom, you just multiply both sides by 10. And you're going to get x equals 100. So there's 100 there, there's 9 there. So that is your 7.5. That's your trapezoids and kites. So now you've got all the quadrilaterals.